Today's video is on integration using residues. In today's video, we are going to find the poles and the residues at each point of f of z is equal to 1 minus e power z by z power 4. See here, clearly, our function f of z is given as 1 minus e power z by, this is z power 4. Now we have to find the poles and the corresponding residue values. See, here f of z can be written as 1 by z power 4 into 1 minus this is e power z. So we can expand this one. So f of z is equal to this is 1 by z power 4 into 1 minus. See here the expansion here is 1 plus z by 1 factorial plus this is z square by 2 factorial plus this is z cube by 3 factorial plus and so on. As this is e power x expansion. Now see here f of z can be written as, so f of z is equal to 1 by z power 4 into that is 1 minus, so if I send minus inside this will be minus 1 minus z by 1 factorial minus this is z square by 2 factorial minus z cube by 3 factorial minus and so on. See here now I can cancel this plus 1 and minus 1. So if I send this z power 4 inside, then f of z can be written as minus z by 1 factorial into z power 4. This is minus z square by 2 factorial into, so if I multiply with z power 4 inside, so this one minus z cube by 3 factorial into z power 4 minus and so on. See here, if I cancel each and every term here, then f of z value is equal to, if I cancel for one time, so this is minus 1 by this is z cube. So this will be, so if I cancel for 2 times, see here, this will be minus 2 into z square minus, if I cancel this for 3 times, so 3 factorial is nothing but 1 into 2 into 3, which is equal to 1 by 6z minus and so on. Now we have to find the residues for the corresponding poles. So for finding the residues, here is a special case. So for finding the residues, the residue of, see here, residue of f of z is nothing but the quotient. See here, the quotient of 1 by z in this expansion. So what is the quotient of 1 by z in this expansion? So here is 1 by z. So here is 1 by z and the quotient is nothing but minus 6. So here the value here is minus 1 by 6 is the residue value corresponding to the function, that is f of z is equal to 1 minus e power z by z power 4. So this is how we have to make this one. So the value here is minus 1 by 6. The residue value for this function is minus 1 by 6. See, first of all, what is given? So it is given to find the poles and the residues at each point of f of z is equal to 1 minus e power z by z power 4. So here it's an exponential function. So we have to expand this one, as we have e power x expansion as 1 plus x by 1 factorial plus x square by 2 factorial plus and so on. So we can use this expansion here. So 1 by z power 4 I have taken outside, and this is 1 minus e power z. So this is e power z can be written as 1 plus z by 1 factorial plus z square by 2 factorial plus z cube by 3 factorial and so on. So if I send this minus inside, if I multiply with minus each and every term here, so minus 1 and plus 1 got cancelled, and after multiplying with z power 4 with each and every term inside, so this is expansion, and after that in order to find the residue of f of z for such kind of functions, so we have to take the quotient of 1 by z. So here 1 by z term is this one and the quotient is minus 1 by 6. So this is the final answer. Thank you so much for watching and staying till the end.